previous video we talked about evaporation using Ke. Okay, so this was what we discussed. Okay, I think it's quite straightforward. Okay, high speed particles leave the water becomes cooler, and then eventually all you're left with are low speed particles, right? Okay, now I don't think you have this column under here in this note at all called factors affecting evaporation. So can you all write this down? Okay, at the last page. Okay, please write it down, um, leaving enough space because I have these few slides, okay, for you to copy it. Okay, now so the factors affecting evaporation are surface area, temperature, wind, humidity, pressure, boiling point. Okay, humidity, as you all should know by now, it is the amount of water vapor in the air. Okay, so okay, let's go. Okay, rate of evaporation, it will increase when the surface area is greater. Okay, because in this manner there are more room for particles to escape. Okay, temperature will also increase the rate of evaporation because faster particles, they are going to move faster, right? Okay, let me on this to slide mode. So surface area, we are already talking about this versus this. Okay, temperature, we are already talking about this. Okay, beaker under flame. Okay, and a normal beaker on its own. Okay, so maybe okay, so I hope you all get the idea. Okay, you may want to draw to signify it as well. I think it'll be quite dry. Okay, if you are just going to copy the words. Okay, but please feel free to pause the video in order to take down the notes at any one point of time. Don't worry about that. Okay, now the wind speed. Okay, moving air affects, yeah, because if the air movement uh, increases, right, it actually increases the rate of evaporation. Okay, now previously I haven't uh, filled in a blank, but I think you should have done it so if you have listened to what I was saying. Okay, okay, now humidity also increases, sorry, in this case it decreases. Okay, now there's only so much, oh sorry, there's only so much room atmosphere can take in order to accommodate the amount of water vapor. So for example, right, imagine I have something like this and the water is here. Okay, this is like a huge water tank. Okay, so this are water. Okay, the part I'm shading. Now if there are a lot of water vapor here because the humidity is very high, okay, the chances of water molecule escaping into here will be low. Okay, however, if I change the situation such that my water molecules in the water vapor in the air are few, okay, it is easier for me to escape. Okay, so the probability of me evaporating will be higher. Okay, so this is what I mean when I talk about humidity. Okay, the next part will be pressure. Reducing atmospheric pressure will, yeah, think about it. Okay, we can discuss this tomorrow. Okay, and how about wet objects? Do they dry faster or slower at places of higher altitude? Okay, faster or slower? Okay, we'll discuss this when the time comes. Okay, reducing atmospheric pressure will increase or decrease. Okay, I think this is something fun to think about. It's similar to this diagram that I drew here. Okay, so you may want to do the same thing. Okay, now boiling point on liquid. Evaporation occurs faster when liquids have lower boiling point. Is it true? Okay, for 5 and 6, I really want to discuss it in class. I think it's discuss worthy material. Okay, so we can do that in class. Okay, yeah, so liquids with low boiling point require less or more. Okay, and uh, okay, so this point I think it's fine not knowing. Okay, uh, so okay, so I think that's the factors that affect the rate of evaporation, and I think it's good for you to know uh, these factors by heart. Okay, you may want to make an acronym for it. Okay, so what what do you have here? STWRPB. Okay, I don't know what you can come up with it, but yeah, you can probably come up with something. Okay, I used to come up with all these acronym to help me remember stuff when I was a secondary school kid. Okay, uh, okay, ST usually stands for street, right? Okay, yeah, then yeah, if you were to change this, you actually get something like this. Okay, something like a rap, but instead of A, it's a B. Okay, I don't know how you are going to memorize it. Okay, but please know these 6 factors by heart. All right, I think that's it for this chapter. We are done with one chapter again. Okay, well done, guys. Okay, we'll discuss all these questions in class. Okay, and the next time I see you in class, I hope to see your notes filled up as well. And if we are done with this chapter, we can finally move on to doing the quiz and all that. Okay, so I'll see you soon in my next video. Okay, yeah, okay, yeah, remember I talked about the giveaway, right? Okay, so before I end, okay, let me use this empty space of the paper to write my question. Okay, now if you can give me a good explanation, right? Okay, let me show you what I have at home. Hold on. All right, okay, so here it is. Okay, I just visited Japan not too long ago, and I got a box of this. Okay, a box has 3. Okay, so you can share it with your friend if you want to. Okay, but yeah, this is what I don't mind giving away. Okay, yeah, okay, so um yeah, but please do not just do it for the sake of the KitKat. Okay, just go ahead and try. Okay, now yeah, the question is this. Okay, I want you all to think about consider this scenario. Okay, um you know that the boiling point of the water will never increase, right? Okay, consider, okay, since boiling point of H2O is constant, right? Correct. So yeah, let's assume constant atmospheric pressure and everything else. Assume constant ATM. Okay, um maybe, okay, never mind, just assume it to be pure. Okay, uh assume pure H2O. Okay, now so we know that this boiling point we are talking about is 100 degrees Celsius, right? Okay, now uh the the thing I want to ask is how can the boiling point increase when heated up. Okay, so think about this. Okay, basically I'm asking you, okay, I have this water that is undergoing boiling. Okay, so when I put a fire under it, right? Okay, and I have a thermometer. How is it possible that this thermometer actually reaches 102? Okay, and this must be pure H2O. Okay, you may want to use the idea of heat capacity, specific heat capacity. Sorry, specific heat capacity. You may want to use kinetic model. You may want to use the idea of internal energy. You may want to use the idea of latent heat of vaporization. Okay, these 4 should help to guide you to giving a very good answer. Okay, let's call this a 4-mark question, shall we? Okay, so yeah, I'm looking forward to the explanation that will be heard from you guys. Okay, and I'll see you back in class. Thank you.